Okay, so what we're doing, you guys, like I told you up in the tutorial room, is we're going to build a to-scale model of the solar system, okay? So this is the sun on a stick here. Everything is scaled down 150 billion times. Okay, so one astronomical unit, which you guys learned what an AU is in class, right? Someone tell me what an AU is. What is it? Yeah, distance from the Earth to the sun, exactly. Okay, so in this model, 1 AU is 1 meter. Okay, so the distance from the Earth to the sun in this model is a meter. So in order to build this solar system to scale, we've done all the calculation stuff for you. You guys just have to help build it so you can look at it and talk about it. Okay, so in one of each of these baggies, this one's for Mars. Okay, you'll find a little, Thomas is going to hand them out. So you'll find a thing that's going to measure the radius of your planet, okay? So take your carabiner and put it around the sun. Okay, and if you guys measure out, this is the radius of the Mars orbit in this model. In your little kits, you'll get a chart that tells you your planet location and the degrees, okay? So, for example, Mars, it tells me the first orbit sticker I'm going to put down is at 0 degrees. So in your groups, one of your partners come up here and look for 0 degrees on this thing that's measuring the degrees, okay? And then go up here at 0 degrees and stick down your plate number 1 under the D. So do you guys get what to do? Then you read off the next angle, someone comes to measure it, you stick down the next plate. Like that, okay? And it gets kind of cramped in the middle, so just be nice to your friends and like step over their strings, and we're all friends here. Okay? Cool? Okay, so you guys come and build it, and Thomas and I and Peter were around to help you guys if you need help. And I have Okay, I think we're done, you guys. That looks awesome. Okay, everybody stand back in the asteroid belt, which is somewhere between Mars and Jupiter. Okay. So if you guys still have baggies, you just put them on the table with your stuff, okay, when you're after that. Okay, so what we did was we built a scaled model of the solar system, right, where 1 AU equals 1 meter. So this is what it looks like. So you get a better idea of the spaces between things, okay? So it's 150 billion times smaller, I told you guys that. So the inner planets, which is everything inside of where I'm standing, the difference between these little plates is 16 days of the orbit, okay, in steps. 16 days. For the outer planets, Jupiter and Saturn, the difference between the plates is 160 days. Okay, otherwise we would have had a whole bunch of plates to put down and that would have been a waste. Okay, so let's do a little like action model of the solar system. So I need some of you guys to be planets and we're going to show you how it works. So everyone hold up their signs so everyone can see what planet you are. Okay, cool. Okay, so what we're going to do is we're going to look at the motion
Astronomy
of the solar
assignment?
system. Okay, so I'm going to count and I'm going to be like the calendar. And every time I say 1, it's going to be like 16 days have gone by. So I'm going to go 1, 2, 3, and that means 16 days each time. Make sense? So every time I say another number, all the inner planets are going to move to the next plate. So you move to 32, you move to 9, so be careful because you're skipping some plates there, okay? And you guys have to move 1. So then the outer planets, I told you, are every 160 days. So every time I say 10 or 20 or 30, then you guys move 1 for the outer planets. Got it? Yeah? No? Okay, Thomas, you go up. Did you hear that I said? Every time I come to 10, like 10 or 20, then you move 10. Okay? Ready? Okay, so you guys can watch what happens. I gotta make sure Chef and Saturn on board. Okay. Okay, ready? Go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
This guy's a little slower.
21, 22. Okay, so you guys get the point, right? Okay, so Mercury's totally dizzy. How many times did you go around? You have no idea, you lost track. Okay, so maybe 3.5 or 4, right? And then Earth, how far did you go around? Once. Okay, so Earth went around once. Then Jupiter, how far did you move? Yeah, 2 plates, okay? So tell me some trends that you guys notice. What's happening? Tell me. Great, so the inner planets move faster. So the reason why we did only these planets from Saturn in is because this year, 2009, is the International Year of Astronomy. Okay, you guys might have heard that before. And you're taking an astronomy course in the International Year of Astronomy. And what the International Year of Astronomy is it marks 400 years ago, Galileo first used a telescope to look at planets in the sky. And the only planets he could see were from Saturn, okay, to the sun. So that's why we have these planets. Okay, so what we're going to do now is we're going to look at where the even further planets would be. Okay, so Galileo couldn't see them, but we're going to look at it just because it's cool and we want to be nerdy. So Thomas has more signs. So I need somebody to be Uranus. No one's going to volunteer for that one. We have Neptune, and we have Pluto and Eris. And you guys know that Pluto's not a planet anymore, right? Pluto's a dwarf planet, and Eris is a dwarf planet as well. Okay, so Pluto and Eris are dwarf planets. And then we also have Voyager, this spacecraft looking thing. This is why we didn't make it build these orbits, because that would have been the king's butt, right? It's really far away. Okay, next we have Neptune. Okay, here's Neptune.
So that's the Voyager?
Yeah.
That's incredible.
I know.
I can't believe how far out that is.
I know, it's so cool.
That's fairly mind-boggling. So is that like beyond our solar system?
Yeah, I mean, it depends sort of where you define the end boundary of the solar system, I guess. But, I mean, then you sort of have dwarf planets and stuff like here. So it's trucking out of here.
I had no idea it was that far.
Yeah, I know, it's cool. It's cool to see it. Normally you just see numbers in a book, right? And you don't really, like, you can't conceptualize. So today's